Hi, sixth graders. Today we're going to be learning about ratios and equivalent ratios. I want you to follow along in your journals, so please pause right now to set up your journal page with ratios and equivalent ratios as the title. Please set up Cornell Notes, and don't forget to put this into your table of contents with a page number. And when I'm talking about ratios, I am using a ratio to make a comparison. So if I have these blocks, and actually just for the sake of making it easier, I'm just going to have 4 blocks total. So if I look at these blocks here, I have 3 red circles and 1 blue square. So a ratio is just going to compare my amounts together, or my quantities together. And I can write that as 3 to 1. And when I'm writing ratios, I can write it in word form like that, or I can write 3 and I can say 2 with 2 dots like this, 1. I can also write ratios as a fraction, so I can say 3 to 1. All of these ways say the same comparison. I have 3 red circles to 1 blue square. Let's look at how we might use ratios in real life. So I'm going to show you this problem, and it says, in a bouquet of flowers, there are 7 daisies and 17 roses. Write the ratio of daisies to roses in 3 different ways. One thing that's really important when we have ratios is the order that they tell me the quantities. So my first quantity they want me to do is daisies, and the second one is roses. So if I'm going to set up my ratio, I have 2 quantities. I'm going to have daisies here, 2, I can write 2, and then roses. So if I have, and I go back and read in my answer, it says there are 7 daisies. So my first quantity is going to be 7. So I have 7 daisies. And my next quantity, my second quantity, are the roses. There are 17 roses. So I can write that here. 17 roses. So I can write my ratio as 7 daisies to 17 roses. I can also write that with a word, so I can say 7 daisies to 17 roses. Or I can write it as a fraction, and I can say 7 daisies to 17 roses. Notice in each of the ways I wrote them, I have daisies first, and daisies are in my numerator, and daisies come first in the word problem. Sometimes when I'm looking at ratios, I might need to pay very careful attention to what my question's asking me. So, if I have this picture and I have all of these pool balls, the question could ask me a few different ratios. So one ratio, it could ask me stripes to solids. Stripes to solids. Well, they don't give me any numbers in the word problem, so I'm going to have to count. The first number of balls I'm going to count are the stripes, because that has to go first in the ratio. So if I count striped balls, I have 1, 2, 3, 4, 5. So I'll write that here. I can say 5 stripes, and I can say 2. Let's count how many solids. 1, 2, 3, 4 solids. So I can write that there. 5 stripes to 4 solids. But sometimes I might be trying to find a different ratio. Maybe I might be trying to find the stripes to the total number of balls. Remember, this pound sign means number. So if I have stripes again, I have the same number. So I'll have 5 stripe balls to the total number of balls. So the total number of balls also includes all my stripe balls. So let's see how many balls I have together. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 5 to a different quantity, 9. My ratio is 5 to 9. Next, we're going to explore something called equivalent ratios. So if I write equivalent ratios. Equivalent is a fancy word for equal. Equal ratios are very similar to fractions. In fact, I would say since we can write a ratio as a fraction, that ratios and fractions work the same way. So an equivalent ratio are ratios that represent the same relationship. So if I had a ratio of, let's say, 3 to 4, I have 3 roses to 4 sunflowers. I can represent the same relationship by multiplying each of my terms of the ratio, so each of my 2 quantities, by the same number. So if I wanted to find an equivalent ratio that was greater than this one, maybe I would try to multiply both of my terms by 5. Times by 5 times by 5, which would be equal to 3 times 5 is 15, and 4 times 5 is 20. So 15 to 20 is an equivalent ratio to 3 to 4. And you can find equivalent ratios that go on forever. So there's equivalent ratios that go on for infinity. They go on forever. So if I just were to randomly pick another number to multiply by, maybe I was going to multiply by 2. I could say that 15 to 20 is the same as 30 to 40, which means that if 30 to 40 is the same as 15 to 20, 30 to 40 is also equivalent to 3 to 4. Equivalent ratios don't always have to be multiplied. You can also divide. So if I had the ratio, let's say 12 to 4, I could divide each term by 4 to get an equivalent ratio. And I could say that is equal to 12 divided by 4 is 3, 2, and 4 divided by 4 is 1. So 12 to 4 is the equivalent ratio as 3 to 1. Now remember, you can also write ratios as fractions. So if I were to look again, I could see that my ratio of 12 to 4 is equal to 3 to 1 can also be written as, let's do blue. 12 to 4 is equal to 3 to 1. And here we can see the relationship between ratios and fractions. Let's look at how we can use equivalent ratios to find real-world quantities or relationships. So this problem says you volunteer at an animal shelter and need to order supplies. The ratio of kitten supplies to adult cat supplies for each category is equivalent. So I have my categories here, and then I have my ratio of kitten to cat. So we're trying to fill in this table. There's 2 quantities that we do not know. I know this one right here. And I know that my ratio is going to be 42, let's see, 42 to 56. And I know that can be equal to a ratio that has the second quantity as 8. So I like to recommend putting my ratios in fraction form. So I'll say 42 to 56 is equal to something over 8. And now in my head, I'm trying to think, what did I multiply or divide by to change these two numbers? So I know this one's bigger, so I divided to get here. And I know 8 times 7 is 56. So I know that I divided by 7 to get to 8. So I'll write that. I divided by 7 to get to 8. And anything I do to the bottom, I have to do the top. So I'll divide the top by 7 also. And I know 42 divided by 7 is 6. I can fill in that quantity on the table. Now, I also know that 42 to 56 is equivalent to something 126 to something we don't know. So let's write it in fraction form again. I have 42 to 56 is equal to 126 over something. So what do I have to do to 42 to get it to 126? If I can't recognize that relationship right away, I can do maybe repeated addition to find out how many times 42 goes into 126. But I can see here that I know 40 times 3 is 120. And I know that 2 times 3 is 6. So I'm going to say that 42 times 3 gets me to 126. And I have to do the same thing down here. I have 56 times 3, which gives me 168. And you can always multiply in your scratch notes, like 56 and 3 to find that answer. So I can write in 168 to that table.